Welcome back. So now that we have visuals looking pretty good for our Arcane Shards ability, it's time to start thinking about damage. Now for Arcane Shards, I'd like to have radial damage. I'd like to be able to cast this, and for each of these shards, I'd like to cause more damage the closer my enemies are to those individual shards, and they'll take a little bit of damage as their distance increases to those shards. So radial damage with a fall off. And if we're going to be implementing damage that has a fall off, we're going to need some parameters. Now, I'd like to take a look at one engine function. If I double shift to search, I'm going to search for radial damage with fall off. And we have a gameplay statics function, apply radial damage with fall off. Now, this is an interesting function. In fact, Unreal Engine's damage system itself is quite interesting. It has damage capabilities, but it doesn't really have a built-in concept of health. You're supposed to do with these damage functions what you need for your project. So apply radial damage with fall off is just going to perform this algorithm where it actually sees which actors are overlapping with it, and for any actors overlapping with it, it's going to, if we scroll down to the bottom, call take damage on it. So it calculates the fall off using its own algorithm. It performs the sphere query similar to what we've done in one of our functions in our function library, and then it ends up calling take damage, and take damage is a function that is virtual and can be overridden in any actor. And so it's up to us to receive that value passed through for the damage calculated and take damage. So apply radial damage with fall off is something we can use. We can take advantage of the built-in engine capabilities, and then we can choose how to handle that damage. But apply radial damage with fall off requires some parameters. It takes in a base damage amount, and it basically nerfs that damage depending on how far away the target is from some origin. And it uses two spheres, a minimum and a maximum sphere. One sphere has an inner radius, one sphere has an outer radius, and any actors that are within that inner radius get the full amount of damage, that base damage passed in, and any actors that are outside of damage outer radius, they get the minimum amount of damage passed in. And then any actors in between those two radii have base damage with some fall off, some percentage taken off of that damage depending on the fall off chosen. And there are different types of fall offs. There's linear fall offs, other types of fall offs that are smoother curves, such as cubic mathematics functions. And if you want the details, you can always look at the implementation here in this function to see exactly how that radial damage is calculated. But if we're going to call this function, we need some of these parameters. Notice there's a damage fall off parameter, and if we look at how that's used, we see that it's passed into radial damage params. If we go to this, we see that it has these base damage, minimum damage, these parameters, right? And it also has get damage scale, which returns the damage done at a certain distance. This is defined in damage events. If we look for get damage scale, it has a distance from epicenter, and it checks the damage fall off here. It sees if it's equal to 0, then it says no fall off, or inside inner radius means full effect. It returns 1. This is a scale, by the way, so we're scaling damage by this. But notice here, it's calculating an interpolated scale. It's creating a damage scale set to 1 minus some value. This is a ratio. It's the validated distance minus validated distance inner radius, so the space in between the inner radius and this distance, divided by the validated outer radius minus validated inner radius. So it's scaling outer radius. So it's setting damage scale equal to 1 minus this ratio here, which means damage scale is going to probably be less than 1. And then it takes that damage scale and it calls power on it. It takes damage scale and raises it to the power of the damage fall off. So we're taking a value that's either 1 or smaller, so smaller than 1, say 0.25 for example, and we're raising it to a power. And if that power is smaller than 1, then damage scale is going to get smaller. I mean, think about it. Let's say damage scale is 0.25, and let's say damage fall off is 2. Well, 0.25 times 0.25, that's a quarter of a quarter, right? If it was 0.5, then that would be half of a half. What's half of a half? That's a quarter. So raising a value that's less than 1 to a power that's greater than 1 is going to make it smaller. So if we just want to have this linear fall off, we can just have a damage fall off of 1. Otherwise, if we want a harsher fall off, we can use a higher value for damage fall off. So that's how damage fall off works. And now we understand that if we're going to be using our built-in apply radial damage with fall off and responding to it, then we're going to need some parameters. Those parameters are going to be a radial damage minimum, a radial damage origin, a radial damage inner and outer radius, a fall off if we want that, otherwise we can hard code 1. And then we have a bunch of other things such as a damage type class. Now we're using gameplay tags to identify our damage types. But damage types are essentially classes that you only add static functions to if you add anything to them, because we never instantiate instances of them. We just use the class, so you can use it as a static class like an identifier and add static functions if you want. You could subclass this and give it a gameplay tag. I don't think we really have any uses for it in this project. And of course, we have a damage prevention channel if you want to prevent damage for any specific channel. So we're going to create some radial damage parameters, and I'd like to add those to a couple of our types. I'm going to go to Aura ability types. We have .cpp here, and I'll open the header file. And we have F damage effect params. I'd like to add some parameters for radial damage here. And we also have the effect context, and this will be a good way for us to carry radial damage params with us throughout the pipeline if we want to access it, say in execcalc damage. So that's what I'd like to do in this video. I'd like to create some radial damage parameters, and we're going to start by adding them to F damage effect params. So down here at the bottom, I'm going to add a few parameters. One will be a Boolean, and I'm going to call this B is radial damage. And it'll be false by default, so if we never set it, then we'll never have radial damage, and I'll make it blueprint read write. Now, in addition to this Boolean that we can check to see if we even have radial damage, we can have a few radial damage parameters. We're going to have a float, and this can be our radial damage inner radius. We can have a float radial damage outer radius. And we can initialize these both to 0. And we can also have a radial damage origin, which can be an F vector. So we'll make an F vector radial damage origin. We'll initialize it to the 0 vector. And with that, we should have enough information. Now, if we really wanted to, we could have a radial damage minimum amount, and that could be separate from our base damage that we have here, but I'm just going to use 0 for my minimum radial damage. And with that, let's add blueprint read write to all of these in case we want to set them from within blueprint if we make one of these structs. Now that we have these 4 radial damage properties, we're going to want to make sure that we're setting these in our damage effect params when we make them with our gameplay ability Aura damage gameplay ability. And that means Aura damage gameplay ability should have the option to be radial. You see, we want radial damage for arcane shards, but for that reason I want our whole system to be capable of radial damage. And that way, when we have another radial damage spell, we don't have to reinvent the wheel. So I'm going to go into Aura damage gameplay ability. Here's the CPP file. I'm going to go into the header as well. And we're going to add some radial damage parameters, and they're going to be identical to our damage effect parameters, namely these 4 here. So I'm just going to copy them, and over here in Aura Damage Gameplay Ability, I'm going to go ahead and paste them. The only difference is I'm only going to make them edit defaults only. We don't need them to be blueprint read write, so I'm going to change their U properties. Now I'm going to take these 4 and set them in our Aura Damage Gameplay Ability function, make damage effect params from class defaults. We're going to go ahead and set these, but really only if this is radial damage. So we're going to first check if B is radial damage. If that's true, then we can go ahead and set the radial damage parameters. We're going to say params dot B is radial damage equals B is radial damage. We'll carry that across. We'll have params dot radial damage origin. We'll set that to radial damage origin. And 2 more, params dot radial damage inner radius. We'll set that to radial damage inner radius. And params dot radial damage outer radius. We'll set that to radial damage outer radius. And now our function for making these params sets them based on the ability class itself, and then we can carry those along whenever we need to apply a gameplay effect. Now, if we're going to apply a gameplay effect and make use of these, we need to decide how. I'd like to set them in the effect context, and that way we can check the effect context to see if it's radial damage at any point in our damage pipeline. Another alternative is to make these set by color magnitudes, but I'm opting for setting them in the effect context, and that way we don't have to crowd up our gameplay effect spec with too many set by color magnitudes, and we don't have to create too many gameplay tags just for those reasons. So I'm going to go back to Aura Ability Types, and we're going to add these into our gameplay effect context. So we're going to have 4 new variables here, which means we're going to have a few steps, including determining how these should be serialized. So just after knockback force, we're going to add these 4 variables. And if I'd like to be lazy, I could go back to Aura Damage Gameplay Ability, or just scroll up to F Damage Effect Params, and I can just copy them from here. Starting it is radial damage. So I'm going to do that, and I'm going to paste them down here, only they're not going to be blueprint read write. They're just going to be U properties. So now we have a new bool, 2 floats, and an F vector. And they're all initialized. So because these are protected, we're going to need getters and setters for each of them, starting with the Boolean and working our way down. So I'm just going to add the getter here. It's going to be bool is radial damage, const, return B is radial damage. And while I'm at it, I'll make the setter as well. Void set is radial damage, takes a bool, B in is radial damage, and sets B is radial damage to B in is radial damage. So this is a bit monotonous, so I can time lapse creating the getters and setters for the remaining 3. So let's do that. All right, so I have my getters and my setters. Now the next step is to net serialize these. Now I'm going to go into Aura Ability Types.cpp, and we're going to flip our bits by checking our member variables. Now the first one I'm going to check here is radial damage. So I'm going to say if B is radial damage, then I'm going to flip the 16th bit. And I'm not going to bother flipping any of the other bits if is radial damage is false. So we're going to check not only are these 0 or the 0 vector, but we're also going to check is radial damage as well. We can do that. We can also just check them here inside of B is radial damage if we wanted to do that. We could say if radial damage inner radius is greater than 0. In that case, we can flip the 17th bit. We can also check the outer radius. So we could change this to outer and flip the 18th bit. And then we can finally check if radial damage origin dot is 0, and we can put a not here. So if it's not 0, then we'll flip the 19th bit. Just like that. Now, if you don't like nesting them, if it seems a little bit confusing, you could take these out and just check both these conditions and have an and check B is radial damage. You could do it that way too. So with that, we can now serialize, and we need serialized bits to accommodate now for 19 bits. So we're going to pass a 19 into that. And after that, we can check these new bits, 16, 17, 18, and 19. So let's go all the way down and check those. So first, we're going to check if rep bits. We're going to use and, bitwise and, that is. 1 left shift 16. And while I'm at it, I'm just going to copy this before I put anything in there and check 17, 18, and 19. So if we flipped 16, we can go back up and look. That's going to be for is radial damage. So what we'll do is we'll take the archive and we'll archive B is radial damage. Now, if this bit has not been flipped, there's no point in checking these other 4. So if you wanted to, you could also put these inside here as well. Now, we can check if rep bits has its 17th bit flipped. And the 17th bit, if we remind ourselves up here, is radial damage inner radius. So we can archive that float. So we'll say AR, radial damage inner radius, and 18 is the outer radius, so AR, radial damage outer radius. And now for the origin, which is an F vector. So how are we going to handle the F vector? Well, we've seen that we can handle net serialize for F vectors using the F vector net serialize. So we're going to do that with our radial damage origin. We're going to call net serialize, and we're going to pass in the archive. We're going to pass in the map and be out success. And with that, we're serializing our radial damage parameters. Okay, so that's a good start. We now know that our effect context can accommodate for radial damage parameters, as well as our F damage effect params as well, and our damage gameplay ability now has radial parameters. And we'll just set that B is radial damage. It's set to false by default. And if we never set it to true, then the context doesn't carry it along. It doesn't even serialize it for replication. So we're not picking up any bandwidth across the net if we're not using these parameters. And if B is radial damage is false, we don't serialize any of these 4. So that's a nice optimization. So with that, we can go ahead and compile. Looks like I have the editor open. I'm going to close it and just compile, make sure I have no errors. And with that, we're now set up and ready to use our radial damage parameters. And we'll do that next.